Hi, I'm Dr. Paul Quinn, and I'm the Degree Programme Director for the MSc in Hydrology and Water Management and the MSc in Hydrogeology and Water Management in the School of Engineering. And you'll get to live in this great old city of Newcastle in the north of England, which is a great place to study, to live, and to work. And you'll be situated in the School of Engineering, and we're in civil engineering. And the university is famous across the world. It's got lots of great awards, and it's a research university, part of the Russell Group. We attract students from all over the world, over 100 nationalities, and thousands of students and lots of staff. But we all know we're enduring a climate emergency, and we will all need water for drinking, for food production, but also a place to live. We've got to protect the ecological systems as well. But our speciality is really protecting us from the future. So if the world is changing, we need to protect ourselves from floods and droughts. And we all live in catchments. That's the one thing that's common. So we need to have a safe place to live, you and me and everybody. Okay, so what is it about our programs? Well, the common material is water management. So basically, you'll be looking to have a common set of skills to make you useful in solving water-related problems. In hydrology, you'll probably focus more on the surface systems that will be related to the climate and things such as flood risk, the hydrology and the hydraulics of those issues. And in hydrogeology, you'll be prepared for a career where you are the specialist in groundwater, and you can bring that to the issues of water management. So we're looking for technically able people who are used to working with data, models, informatics, visualization and communication. You'll be meeting some of the world leaders in their fields who will give you this problem-solving ethic. You'll be working in brilliant laboratories with brilliant facilities, and we believe that this gives you an employability edge. Okay, you will get a job. Okay, either in consultancy, a lot of our students work in governance, and many go on to do academic research. So we've got about 100 staff. We call ourselves a little family. We've got 12 academic staff, lots of postdoctoral research fellows and research associates, but we have lots of PhD students. And we've got some great facilities such as our hydraulics lab and our urban sciences facility. And each year we often have 50 to 20 MSc students. A nice little community. It would take forever to go through all the people in the list, but if you go to the website, you can see that we've got the length and breadth of water sciences and climate and hydrogeology. So there's lots that we can attract you with. We're accredited from the Chartered Institute of Water and Environmental Management, and we're closely linked to the Institution of Civil Engineers, and part of this institution is the British Hydrological Society. And basically, when you come onto our course, we have these common modules, the water management. So the first semester and the first part of the second semester, you will learn some core materials about hydrology, management, quantitative methods, modeling, GIS, and lots of other associated modeling techniques. But then you get a chance to specialize. So if you're going down the hydrology route, you will probably do flood risk management and climate change. You go down the hydrogeology route, you do groundwater assessment, borehole design, and then you have an option or two that you can pick as you go through the time, and then you'll have a dissertation project. Okay, so we're really trying to address the major global issues as they arrive, but the unique thing we do is we give you the tools, the methods. You're not just talking about the problem, you're going to solve the problem. And you are going to be right at the cutting edge of academia and methodologies. And the world knows that we've got a problem. We have the Sustainable Development Goals. And if you were to look through nearly all of these, you'll find that water is at the heart of them. And we work all over the world. So just as an example, flooding. You know, why have we got so much water falling on our systems? Why is it changing? You know, we really need to understand why the problems are arising. But then we have to think through it. What does it mean on the ground to the people, and how does the economy learn to live with floods or to mitigate for floods? And the rural systems have changed. The world is changing quickly. So over the past 50 years, how we use the land has completely changed. This whole function and its level of pollution has changed. So we need to think about sustainability. And we look at lots of technology. So our main tool is probably modeling. So we acquire data, we put them into models, we use them to help decision making. And therefore, overriding concepts such as Earth systems engineering and hydroinformatics are at the core of our modules. So we've got lots of tools. So we can look at management. So we can look at urban or rural management. Let's just take an example from my own work of something called Farm Integrated Runoff Management, FIRM plans. Here we have a barrier that looks like it's just sitting in the middle of the field, but when the big storm comes along, it slows down the flow, it stores some water, and a day later, it's gone, and it turns back into a farm. And you can link lots of different interventions together to make what we call a treatment train, and so we call this catchment systems engineering. We have to be able to manipulate the world that we live in so that we can get our food, get our water supply, but also have a safe place to live in the future. Here we are working in an actively eroding gully area, and we're actually putting logs into the gully in order to stabilize it. Now, it's impossible to get in there with a big digger, so here we have Jimmy the horse helping us out. And we call this one kerplunk. And equally, in the world of groundwater, there's only 3% of the water available to us, but 98% of it is in the ground. So it's no surprise that we'll be becoming more and more reliant on groundwater, and hence the need for groundwater specialists and hydrogeologists. We work all over the world. We work at national scales in terms of getting water from A to B, and we need to make people talk to each other and understand each other. And we work at local communities. So here we're encouraging the local villages to actually make their own measurements, to understand their own system, and therefore optimize and make it more sustainable. We have the very famous CityCat model, which is used for simulating floods across urban areas. And this is used to understand the energy and the flow regime. And recently we had an enormous storm called the Toon Monsoon. And we were able to almost like test the model out, and we were able to see that whether the model was saying there was flooding, you could see it did actually flood. And this flood stopped the whole of the town absolutely still for 2 days. We have lots of ways of visualizing the Earth as well. So we have our own 3D geological models, and we can start to think about, so this is also Newcastle, and we're thinking about where the water is, both on the surface and in the ground. A lot of our knowledge comes from basic instrumentation, so you'll get a chance to go into the field and see some equipment and all sorts of ways of measuring water quantity and quality on the surface, climate parameters in the soil and in the rock. We've got our own hydraulics lab, completely refurbished. This is the brand new Kateja flume, and we're using that for all sorts of basic insights into how to manage the world. We also work globally on some of the world's biggest projects, such as the Global Energy Water Cycle experiments. We also host the Urban Observatory. So Newcastle has thousands of probes across the city, watching how the world functions. And that's giving us great insight as to how to manage cities better. And we also have the National Green Infrastructure Facility at Newcastle, where we're testing out a whole range of green technologies and sustainable drainage systems. And you'll get a chance to see this when you come. In the end, you'll use these facilities to do your own project. I've just got a couple of examples here. One is natural flood management in Upper Weardale, which is kind of an alternative way to manage flooding. And here's one related to hydrogeology, trying to understand the dynamics of chalk-dominated aquifers. So that's it. We'll be investing in you. We've got so much investment We've got all sorts of new labs and research facilities that you'll be able to call upon, such as state-of-the-art computing and a brilliant award-winning library. We work with lots of other organizations, and you'll be supported every step of the way. Okay, so if you ever have any issues, just come and see us and we'll get you into the job that you need. We also can help you with scholarships, and we've done some world-leading impact. So for instance, we now have our new water hub, and we also have our UCRIC National Grid Infrastructure Facility, a £10 million investment program. And you know, Newcastle for everybody. We hope you'll understand our equality, diversity, and inclusion ethics. And you know, come to university, have a great time, make friends, but learn a lot, and then go out and be useful to society. It's an absolutely unique place to live and work. It's just, you can easily get to the coast, you've got a vibrant social scene, and it's a classic old town. And then we will get you into a job. Everybody in our MSc gets a job. Don't worry about that. And where these guys actively come and recruit you, and so you will have a good experience in Newcastle. So there's lots of reasons to come to Newcastle. You will get the best education, and you will come out with a good competitive salary. So I'd like to thank you, and thank you for your time.